We're going to finish up section 9 for today and talk about the end of vectors. And then tomorrow will be a review day with a quiz on Wednesday. What we're going to talk about today is adding and subtracting the algebraic vectors. So we know that we can write a vector in its component form using the i's and j's, or when we handwrite them, it's I hat and j hat. So if we have a vector v, that is a1 I hat plus b1 j hat, and a vector w that is a2 I hat plus b2 j hat. If those are two vectors, then we can add them by adding the horizontal components times our I hat, and then adding the vertical components and multiplying that by j hat. And likewise, if we want to subtract, we subtract horizontal minus horizontal and vertical minus vertical. What this means is when you have component form, you only combine the parts that go in the same direction. This is really helpful when we start looking at physics applications of these of vectors. We also can do some scalar multiplication. These are two very simple operations. Scalar multiplication says if you have your vector v and k is a scalar is just a number. Then if you multiply k times vector v, you multiply the x component by k and the y component by k. It distributes over the vector. So let's look at some examples. I have vector v that is 4i hat plus 5j hat and w that is 3i hat minus 6j hat. If I want to add v plus w, you really can just do this and think of it as combining like terms. I have vector v and I want to add vector w minus 6j hat. And I'm going to combine. I have 4i hat and 3i hat for a total of 7. I have 5j hat and minus 6j hat for a total of minus 1j hat. And that will be my final answer. There we go, unfrozen. If I want to subtract, we need to make sure we distribute the subtraction. So I have 4i hat plus 5j hat, and I need to subtract the entire vector w. So we would need to distribute this subtraction so that it says minus 3i hat plus 6j. And then I can combine my like terms. 4 minus 3 is 1i hat. 5 plus 6 is 11j hat. And there's my final answer, I plus 11j. So it's 1 in the positive x direction and 11 in the positive y direction. If we want to multiply by a scalar, I distribute the 3 over the entire vector. So the original vector was 4i plus 5j. I now get 3 times 4 is 12i hat, plus 3 times 5 is 15j hat. If you look at this graphically, what happens is when you multiply by a scalar, you go in the exact same direction, but the magnitude gets multiplied. Here I have a more complicated operation, 2v minus 3w. I'm going to 2 times vector v, 4i hat plus 5j hat, minus 3 times vector w, which was 3i hat minus 6j hat. And I'm just going to follow order of operations. I'm going to multiply first, distribute the 2. That's 8i hat plus 10j hat. Distribute the negative 3 minus 9i hat plus negative times negative is positive 18j hat. And then combine my like terms. I have 8 and negative 9 for a total of negative 1 in the x component. And 10 plus 18 is positive 28 in the y component. So the operations, really, you just treat it as if these are different variables when you're doing the operations. But remember, what you're doing is you're talking about the x component and the y component of the vector. This is the symbol we used the other day. The double lines on each side is magnitude. The formula for magnitude is square root of a squared plus b squared. So v, the vector v, was 4i hat plus 5j hat. So this is the square root of 4 squared plus 5 squared, 16 plus 25, that's square root of 41. These vectors are given in the other component form where we use the pointed brackets. But this is, again, this is the same thing as 2i hat minus 3j hat. They're just in a different form. If we want to find the sum of those 4 vectors, I'm going to add all 4 of them together. It's the same rule. I'm going to add all the x components to get my new x. 2 plus negative 5 plus 4 plus negative 1. And to find the y component, I'm going to add all of my y components. So -3 plus 1 plus -2 plus 4. This is -3 plus 4 is +1 minus 1 is 0. -3 plus 1 is -2 plus another -2 is -4 plus 4 is 0. When I get a vector that the x and y components are both 0, that's a vector that goes 0 in the x direction and 0 in the y direction. This is the 0 vector. Remember, the 0 vector has a magnitude of 0 and has no direction. I'm going to take these same 4 vectors and add them geometrically. So I'm going to pick somewhere to start. And then the first vector, v, was 2, -3. So I go right 2 and down 3. So there's v. Then I'm going to add head to tail. From the end of that vector, the vector w was -5, 1. 5 to the left and up 1. I'm going to go here. Then I'm going to add vector u, which was 4, -2. I'm going to go right 4, +4 over, 1, 2, 3, 4, and down 2, 1, 2. Goes there. And then my last vector, negative, goes -1, 4. So I'm going to go 1 to the left, 1, 2, 3, 4 up. And if we look at this, when we add those 4 vectors together, we end up at the same point we started. The total is the 0 vector that goes nowhere. You can see it algebraically, we can see it graphically. A couple other problems we can do with vectors. This is going to look a lot like what you did earlier in this chapter. I want to write the vector v in my component form, a I hat plus b j hat, given the magnitude and the angle it makes with the positive x-axis. So here I have a vector that's at 150 degrees over here with a magnitude of 6. So if I was drawing that vector, it would be 150 degrees with a magnitude of 6. I want to find the x and y components of that vector. Well, if this is 150, we have, guess what, a 30, 60, 90 triangle. When the hypotenuse is 6, the shorter leg is half of that is 3. Take the shorter leg and multiply by square root of 3 to get the longer leg. Make sure that you look at the direction here. I'm going left, so this should be negative. I'm going up, so the 3 is positive. So I want to write this in component form. A times I hat plus B times J hat. Another example, the magnitude is 8 and the angle is 225. So this vector comes down in third quadrant at an angle of 225. So inside we have 45 degrees. I need the x and y components. The magnitude is 8. It's a 45, 45, 90 triangle, so I take the hypotenuse and divide by square root of 2, which gives me 4 square root of 2. Both legs are congruent. If I'm going left and down, they are also both negative. So my x component is -4 root 2. I multiply that by I hat. And my y component is -4 root 2, and I multiply that by j hat. The last examples get us a little bit closer to how some of this looks in physics. Here we have a child pulling a wagon with a force of 40 pounds. When a child pulls a wagon, they don't pull it straight in along the ground. They don't crawl in front of it. They pull it on the handle. So this child is pulling it at an angle of 30 degrees with the ground. So the 40 pounds of force is not all going in the direction of the motion of the wagon. So by breaking it into its components, we can break it into how much of that force is going in the direction of the component and how much of it is pulling upward. That would eliminate things like friction and things like that. So here, this is a 30, 60, 90 triangle. So hypotenuse, divide by 2 to get the shorter leg, multiply shorter leg times square root of 3 to get the longer leg. I'm going to write this in terms of I hat and j hat. The x component is 20 square root of 3, and the y component is 20. Here I have a man pushing a wheelbarrow up an incline of 20 degrees. So here's my incline of 20 degrees, which is not very steep, and he's pushing it with a force of 100 pounds. That force is going in the direction of the incline. we could break it down into the horizontal and vertical components to see how much you need to push it up over gravity, to see how fast it's going to go, all of those sorts of things. In this problem, in order to get the x and y components, I would need to use trig because it's 20 degrees. So cosine of 20 would give me the x component over 100, horizontal, or adjacent over hypotenuse, and sine of 20 would give me the y component over 100. Opposite over hypotenuse is sine. And then I would solve this by multiplying the 100 over to get A, and same with B. And then I would have to go to my calculator and make sure I was in degree mode. And what we get is an x component of 93.97 and a y component of 34.20. And it should make sense that the x component is larger because at a 20-degree angle, more of the force is going horizontal than vertical. As this angle got steeper, more of the force would go in the vertical direction. So you're going to do 9-4 day 4 today, and then you're going to do review tomorrow and a quiz on Wednesday.